Right now. Hey, welcome back, everyone. Happy 2025. It's good to be back with our weekly seminar series. As I was saying a moment ago, I am working within my powers and capabilities to make the seminar time become 4 p.m. instead of 4:30. I was trying to reach back in history to remember why it was that we set up the seminar time at 4:30. It's been true for years, right?
Must be classes scheduled.
It must have been at someone's class schedule once to cause this. So I think that we'll go back to 4 p.m. at some point, hopefully very soon. But today at 4:30 p.m., we have the pleasure of having a returning colleague. And he will tell you more about this, but Professor Chris Atkinson joined the Ohio State University 4 years ago.
3.5.
3.5 years ago, with this role of Director of Advanced Mobility Initiatives at Ohio State. There was a lot of excitement about his joining us after having spent much of his previous career between West Virginia University, his own private activities with a company that he ran for a number of years, then back to West Virginia University, then with ARPA-E for almost 6 years. Then he came to Ohio State thinking, okay, I'm back into the world of universities. And 6 months later, the U.S. Department of Transportation says, no, we need you to launch a new program. I'll let you explain a little bit maybe about what you did in the past few years. But that assignment that lasted approximately 3 years just ended, and Professor Atkinson is back with us. So watch out, because you might get some extra homework assignments.
Thanks very much, Georgia. People online, can you hear me and see the slides okay? Well, I'll start sharing in a moment. And somebody online say yes or no?
Unmute and speak.
Unmute and speak. Yes.
Yeah, you're good.
Barbara Beck is giving the
You're
thumbs
good,
up.
Chris.
Okay, great. Thanks very much.
Awesome.
Okay, good afternoon, everybody. As Georgia says, I'm Chris Atkinson. I'm a professor of mechanical and aerospace engineering, returning to Ohio State. As Georgia said, I was at the U.S. Department of Transportation for 3 years, helping set up ARPA-I, the Advanced Research Projects Agency for Infrastructure, having spent 6 years at ARPA-E for energy in the U.S. Department of Energy. So energy, transportation. I was going to say, I'm sure that my title includes both, and it does. Title of the talk is Where Are We? Evaluating the current status of vehicle electrification and vehicle automation. Let's talk about vehicle electrification first. I believe that you need to practice what you preach. I'm an owner of 2 EVs, as it turns out. And also you're in the presence of an influencer, 105,000 views of my post when I got my very nice yellow Mach-E, which is in the parking lot. And then I got a shout out from Jim Farley. I'm very pleased about that. I've owned 17 new vehicles in 31 years, 11 gasoline, 1 diesel, 1 flexible fuel, 1 HEV, 1 plug-in hybrid, and 2 EV. I believe the future is electric, for light-duty transportation at least. But it's simply a matter of how and when. The reality of owning an EV, where's David? David knows about this. And I've termed this the good, the bad, and the ugly, right? 6 cents a kilowatt hour electricity at the retail level in Ohio. That's what I pay, a little more than 6 cents at home, and I recharge it mostly at home. This is a scandalously low number, and I mean that. You shouldn't be paying that little for electricity. What it means is like 2 cents a mile for the energy for my vehicle. My wife has a Mercedes SUV, and when gasoline is $3 a gallon, which it is roughly now, 20 miles per gallon, it's 15 cents a mile, right? So roughly 10x. That's the good. The bad is that you can travel 100 miles away from home only to find the chargers have just been swapped out for 350 kilowatt chargers, which is absolutely fantastic, but they're not available and haven't been commissioned. You then have to backtrack 50 miles in order to charge. That's the bad. The ugly is this. Look at this. Z charger cable, look here. No charger cables. That was when I was at P-TAC Airport in Seattle in the summer. Someone had cut every one of the 6 cables to take to a junkyard for the copper, right? So it's problematic. It's very, very difficult owning an EV. If you drive, as I say to people, you drive 200 miles, it's the very best vehicle you could own. Goes like a bullet, very comfortable, fantastic, very cheap, wonderful to drive. You drive 201 miles away from home, you run into enormous potential problems.
And also, pardon me, but
Sure.
when you go to a fast charging station, it's not 6 cents a kilowatt.
No, it's not 6 cents a kilowatt hour. And I have another thing which I couldn't find on my phone, but in Cambridge, Ohio, which I stop at a lot, had 350 kilowatt chargers. The last time I was there, they were running at 35 kilowatts. They've been throttled to 10%. Why? No explanation given. Okay, so why are we talking about energy and transportation? For this reason here, transportation is roughly 30% of our energy usage in the United States. As you well know, because we have internal combustion engines that provide the predominant amount of motive power for transportation, enormous amount of rejected energy. Electricity usage is the tiniest filament here. You can see the vast majority of the fuel that we use for transportation is in petroleum. Some of it comes from biomass that's in the form of ethanol and a bit of biodiesel. Right. These are the CO2. This is the Sankey diagram, as you know, from sources and sinks. This is the Sankey diagram for CO2 emissions. And of course, for transportation, again, it's roughly 1/3 of CO2 emissions. So if we're interested in decarbonization, we have to pay attention to transportation. Our transportation reality in the US today, we drive 101.5 thousand miles a second. The vehicle fleet in the United States, light and medium and heavy duty vehicles, drives 100,000 miles per second, every second of every day of the year. Fuel consumption is 6,100 gallons per second, split between gasoline and diesel, 74% gasoline. This tanker here, which is truncated, you know, the normal tanker, the big one, the biggest of the single trailer tankers, every 1.5 seconds in the United States, 24 hours a day, 365 days a year, the equivalent of one of those every 1.5 seconds couples into the fuel system. Of course, some of our fuel is delivered by pipeline, so it's not all tankers, but that's the equivalent, right? Ethanol production, we're at about E13 for gasoline, so 13% of our gasoline pool is ethanol. Biodiesel is about 6.6% of diesel. We used to sell 17 million vehicles a year, new light duty. It's now 16, and about 480,000 medium and heavy duty vehicles are sold every year. Average new vehicle price has actually come down in 2024. It was higher in 2025. EV sales are about 9%. We'll talk more about that in a while. Public EV chargers, really problematic. Okay, so this is the summary. Decarbonization of transportation is a global imperative. If we seek to reduce CO2 emissions, and of course CO2 concentrations in our atmosphere, we have to decarbonize transportation. There's going to be differences across the world due to policies, regulations, societal pressures, and hence the technologies to be used across the world will vary. Generally, light-duty vehicles are being electrified, but we're seeing a reversion to HEV, hybrid electric vehicles, and plug-in hybrids, mainly due to consumer acceptance problems. We'll talk more about that. Medium duty is mostly well suited to electrification and can be a very fast follower, use pretty much the same technologies as light duty. Heavy duty, which includes on highway, off highway, marine and rail to a certain extent, is in a state of fuel confusion. They don't know what fuel to use. We don't know what fuels will be used. Indecision and paralysis. Aviation, remarkably, they hire very good marketers and they hire very good lobbyists. They've determined that there will be this magical fuel called SAF, sustainable aviation fuel, that will fall out of the sky in the right quantities, in the right places, at the right cost, and they will take advantage of that. Currently in the United States, SAF production is 0.1% of jet fuel production, 0.1%. So they need to scale up by 1000x, which means that they will use every last ton of biomass available and more, which means that there'll be none available for light duty gasoline, there'll be none available for any other application. Biomass will be the main limitation for low carbon fuels. And then other zero carbon fuels, hydrogen and ammonia, I'm just dismissing them. They face too many hurdles to adoption to succeed. So if there are people working on fuel cells in the room, I apologize. But pretty much they face too many hurdles to adoption to succeed. Why am I so dogmatic about that? Because electrification is in jeopardy. And if electrification is in jeopardy, hydrogen and ammonia use most certainly is. Okay, vehicle automation, it's 2 decades old, roughly speaking, although people will say it's 7 decades old. It's incredibly difficult, but there's a lot to be gained through connectivity and implementing low levels of automation. We'll talk more about that. Criteria pollutant emissions, by which we mean carbon monoxide, hydrocarbons, oxides of sulfur, oxides of nitrogen, said carbon monoxide, particulate matter, what else is there? That's it. Since the 1970s have declined precipitously in the United States. Even though vehicle miles traveled have trebled, gone up by 3x, criteria pollutant emissions have just dropped enormously. Why? It's the magic of fuel reformulation, better engines, and of course, after treatment, after treatment. Of course, CO2 emissions have not, from transportation, have not decreased. They've decreased slightly, mainly due to improved fuel efficiency of vehicles. I should have that slide, but I don't. But not to the same extent. You can't get a 90% reduction in CO2 emissions unless you go to full electrification. So we collectively have fought since the 1970s for energy independence. You've heard of the first, oil, second, and third oil shocks in the 1970s. And remarkably, even as recently as 2008, we are importing enormous amounts of oil and natural gas. Bear in mind, we imported them from across the world, but we import a lot from Mexico and Canada, which is pertinent today. But in 2018, we crossed that net zero point. We now export significantly more amounts of energy than we do import. We still import some crude and a bit of natural gas. But we export significantly more in the form of finished products and specifically LNG. We're now the world's biggest producer of both oil and gas. And that all occurred in the last 20 years or so. And that's due to the magic of horizontal drilling and hydraulic fracturing. So we fought since the 1970s for energy independence, and we've achieved. It's remarkable. We fought for a reduction in criteria pollutant emissions since the 1970s, and we've largely achieved it. What we haven't achieved is a significant reduction in CO2 emissions. I'm going to show you the same data in multiple ways here, but these are the transportation energy sources. You can see gasoline is fully 50% of our energy. Jet fuel, which is middle distillate kerosene type fuel. And then these distillates, that's essentially diesel fuel. Biofuels, 6%, natural gas, 5%. The 3% includes electricity, which is a tiny, tiny slice of our current energy sources in the United States, transportation. I did warn you that I'd show the same data 7 different ways. Light trucks, which are pickup trucks, sports utilities, minivans, dominate, and then cars and motorcycles, other trucks, which are medium and heavy duty, and then aircraft is roughly 10%. Pipeline fuel is 3 or 4%, and that's used predominantly natural gas compressors, which are used to compress natural gas. Same data again, showing you predominantly gasoline usage in light duty vehicles, predominantly diesel usage in medium and heavy, kerosene or jet fuel use almost exclusively for air, pipelines consuming their own fuel that they pump, which is natural gas, and then rail is predominantly diesel or middle distillate fuels. Water is a mixture. And that's water on inland waters in the United States and coastal waters in the US. Okay, so from the 1970s onwards, we looked for alternative fuels because we needed energy independence. We did not produce enough oil and natural gas for our own use. So from the 1970s onwards in the United States, there was an enormous amount of alternative fuel investigation. What we typically did is we compared any new fuel, be it natural gas, propane, CNG, LNG, methanol, ethanol, DME, hydrogen. Help me out to some of the 1970s and 80s alternative fuels. That might be just about it. We compared them to diesel and gasoline within these 9 categories: the combustion characteristics, their emissions production, how is the fuel produced or generated, its safety, which included things like toxicity and flammability, fuel storage on board vehicles, how it would result in the vehicle range, fuel dispensing and distribution, availability and energy independence. Did it contribute to US energy independence, or did we have to import it? Consumer acceptability, which involves things like vehicle range and so on and so forth, but also the convenience of use and its dispensing, and then cost and economic consideration. The reason I'm showing this is that to a certain extent, when we decided to go to vehicle electrification, we decided to waive many of these. I'm not sure why, but we did. And I'll return to this in a while. So back in the 70s, 80s, and 90s, we came up with methanol, ethanol, propane, CNG, and we evaluated them against all of these. And each of the fuels was found wanting in one or more categories. For example, fuel storage for CNG, toxicity and flammability for methanol, fuel availability, and ultimately cost, and also the consumer acceptability. Would the consumer accept these? And so those fuels, in a number of cases, they did not meet or exceed gasoline or diesel in just one category, and yet we threw them out. Transportation decarbonization in the United States for the last 4 years has been led by the US National Blueprint for Transportation Decarbonization. Relies very heavily on electrification for light duty, sustainable aviation fuel for aviation, and a range of technologies for the off-highway, marine, and rail. This is the editorial. This approach is fundamentally flawed, unachievable, it's uneconomic, it's non-optimal, and it's unfair. Proposed targets cannot be met given the constraints of cost, critical materials, supply and availability, global competitiveness, customer acceptance, or time. I'll talk more about this and justify that. This is the blueprint, which you should know. It's the DOE, DOT, OEA, and HUD. And this is the summary of it, essentially. Light duty vehicles, predominantly battery electric. Hydrogen, long-haul trucks, predominantly. Sustainable liquid fuels, aviation, maritime. Again, as I said to you, aviation at 11% will consume every last available ton of biomass in the United States produced on an annual basis. And this plan doesn't take it into account at all. I just wrote off hydrogen, so you can exclude that. And I've told you that sustainable aviation fuel will take every last available amount of biomass. So it shrinks all of that to that category alone. It gets rid of that. So what does it leave for the rest? Well, it doesn't. That's why it's not well thought out. It's non-optimized. And again, it's not fair. Why is it not fair? Because the marine and rail and heavy duty truck people are there floundering for an energy source because electrification won't do it for them. And because aviation has co-opted every last ton of biomass. Okay? It's completely non-optimal. What the DOE and DOT did specifically was to optimize sort of in one dimension only. They didn't do a full multi-dimension. What is the result? The result is that the President Trump yesterday overturned the electrification essentially portion of this transportation blueprint by rescinding the $7,500 federal tax rebates and yanking back all the unspent money on the electrification, specifically with respect to incentives. So in an afternoon, this plan has been undone. We have to come up with a better plan. Again, why are we talking about energy? Well, because the United States consumes such a lot of it. The top line there is petroleum, which sort of bounces around. It's trending down for a number of reasons, one of which is that vehicles have become significantly more efficient over the last 30 years. You can see this black line here is coal use, which is predominantly used for power generation. has literally plummeted within the last 10 years. Natural gas, contrast, has risen. Nuclear has flatlined for the last 2 decades or so. Renewables are ramping up, but from a very, very low base. Okay? If we wanted to electrify all of transportation today, all light duty, medium duty, and heavy duty, if we could swap them all overnight, every vehicle mile traveled using electrification, it would add about 42% or 2% to US electrical energy demand in the United States. It's doable. It's doable. Of course, it's not doable overnight. It's doable in the long term. Remember, if we wish to decarbonize, then all of that 42% needs to come from renewable, and it's currently 8%. So we need a 5x, 5 times increase in renewable energy generation. That's just a starter. It's just for transportation. That's not electrifying any other portion of our economy, including industrial applications. It's not adding another single heat pump to anybody's home, doing none of those things. It's 5x transportation alone. Okay, this is another way of showing the same thing. What we have to do is the vast majority of petroleum is used for transportation fuels. Some of it is used for petrochemicals, as you well know. Most of the natural gas, 99% or so, no, 90% or so is used for power generation. The balance is used for things like fertilizer production and other petrochemicals. What we have to do is we have to take that fossil fuel share and make it up in these renewables here. Not in the nuclear, of course. Well, perhaps we'll increase the nuclear, but again, it's a matter of time. So we need a massive increase in renewable energy, 5x over today, a huge grid build out. People vary on estimates, but doubling of our high voltage grid is not unrealistic to contemplate, especially because the wind occurs predominantly up the spine of the country and solar is more predominant in the southwest. EVSE availability will need to increase by about 100x. Again, that's an estimate. We need 2x energy storage improvement. Why? Because my vehicle currently drives 200 miles of range, and really most people demand 400 miles. David told me today that he gets 100 miles.
That's the scope.
When it's this cold. Yeah, yeah, it's a significant problem. Or we could increase biofuel production by 10x over today. E13, we could use all of our gasoline and some of the diesel, but that's not likely to occur. Or some combination thereof. Right? That's what is required for decarbonisation. 5x renewable energy, 2x in the grid, 100x in EVSE availability, 2x improvements in energy storage with 10x biofuel production or some combination thereof. So we need 6 revolutions, as I call them. Renewable energy generation, that's the 5x, grid builder, 2x, charging, 100x, critical materials and components. You've no idea, an enormous amount. EV and battery manufacturing, that's actually where we're doing remarkably well. We'd give ourselves sort of a B+ grade because it's easy to put up a new production plant. Sourcing the materials is a different story. Then, of course, the 6th revolution is we need to improve vehicle affordability and the consumer pull. We need to make these vehicles more consumer acceptable from many points of view. Increased range, increased performance, reduced cost, increased availability of charging away from. These things are proceeding at differing rates across different timescales. We're in the beginning of a decades-long transition. It's been artificially pushed in the last 4 years, I would say. It's going to take trillions of dollars, and that's consumers, corporations, and taxpayers, trillions of dollars in the aggregate. Critical material supply, just as an example. As I say, we're doing very well with battery plants. We would require 62 gigafactories. There's 15 have been announced to date, but of those, 4 or 5 have been cancelled in the last year or so. That's without grid storage. If we want to have a significant grid storage, that will then detract from the productions that could be diverted towards transportation. Of course, you've heard about rare earths for motors and many other critical materials are significant. So we need battery materials, rare earths for motors, many other critical materials for everything from semiconductor manufacture throughout. A shift to more mineral intensive energy systems. EVs take 6 times the mineral inputs of a conventional car. Offshore wind plant requires 13 times more mineral resources than the similarly sized gas-fired power. So 6 and 13, enormous increases in critical materials production required. Looming mismatch between material supply and our climate emissions. Copper, a significant shortfall, but the shortfalls in lithium and cobalt are significant. I've ringed these for lithium, graphite, cobalt, nickel, and rare earths. We're going to need between a 7x and a 42x production. That means mining, beneficiating, processing, all three. The scale and scope is mind-boggling. Many mineral supply chains lack diversity. There's oil and natural gas. You can see that the US is now the world's largest producer of both oil and natural gas. Copper dominated by Chile, nickel by Indonesia, cobalt, the Democratic Republic of Congo, rare earths, China, lithium is Australia. And that is Chile. Is that what it says? Yeah. And then refining on fossil fuels and then copper. You can see that the processing of the vast majority of critical materials is dominated by China. So essentially, 2018, we were energy independent. The United States received energy independence. Pretty much on the same day, we decided that we would go all out for electrification, especially on the light duty side. And on that day, we became 100% dependent on China. Not 99, not 90, not 50%, not 5%, 100% dependent. So we flipped virtually on a given day. Went from complete independence to complete dependence. People say, what about recycling batteries? Well, as you well know, once EVs are 100% of sales, who knows how many decades they'll take. Roughly 10 years after that, you can achieve full circularity. So it's whatever the day is that you achieve 100% sales plus 10 years, that's when you can achieve full circularity. Another ironic thing is that lead acid batteries. Lead is a element that's toxic and is vilified, but we recycle something like 99% of lead acid batteries. It's a remarkable achievement. And we recycle, does anybody know what the level of recycling of lithium-ion batteries is today? Probably less than 10%, yes. So, gone from a technology that we vilify, yet has full circularity, to a technology that we think is savior of the world, that even at today's production rates, tiny fraction of it. This is the same sort of data, but it shows you slightly differently. Again, China dominates significantly. So cobalt, for example, NMC batteries, lithium, nickel, metal, cobalt, NMC. I'm losing track. Mines in the Democratic Republic of Congo, of the mining in the DRC, 60% of it is so-called artisanal miners. These are people with picks and shovels and mud pits. It then gets sent on trucks to Brazzaville, where it gets put on ships, gets taken to China, travels inland to Western China, where it gets beneficiated, and then shipped back to the coast, put back on ships and brought to places like the United States. Right? And, we used to do these things called life cycle assessments. But if you look at the LCA for cobalt, it includes none of that. And that is the predominant pathway. So we essentially fool ourselves when we believe that we are undertaking this electrification revolution, if you like, and we believe it's all unicorns and daisies and rainbows. It's not. It's a horrible business. It's a terrible business. Demonstrated by cobalt, for example. And It's not particularly environmentally friendly, and it doesn't show good stewardship. Why do I say that? Again, these are artisanal miners in Democratic Republic of Congo, who operate in mud pits up to their necks. Is that the way to have undertaken energy transition? I would say no. It's an unconscionable way of thinking. So supply chain issues. The pandemic taught us that if you don't control your full supply chain, you don't control your own destiny. And it's full with an asterisk. And the asterisk means it really needs to be full. You have to control your full supply chain. Otherwise, you're at the mercy of others. Cost reduction. We've seen significant cost reductions in lithium-ion batteries. But 100 kilowatt hour, which is slightly higher than the battery pack in my car and David's, is $15,000. And again, the average vehicle today is $47,000, $48,000. So it's fully 1/3. And that's the cost of it to the OEM. You know, there's no markup or anything. 1 megawatt hour Tesla semi is $150,000 for the battery pack. You can buy a Class 8 tractor trailer today, a beautiful one, for $150,000. Battery pack in the Tesla semi essentially costs that much. Okay, volume. These are costs per kilowatt hour between China, North America, Europe, and India today. And China already has a significant cost advantage. The right-hand side here, this is the planned capacity in China for lithium-ion batteries. This is the demand forecast for all applications. And that's the maximum potential size of the China vehicle market. The maximum. If every vehicle in China was an EV, that's how much they were used. So by 2030, they're going to have a 2 to 3x overcapacity of lithium-ion battery production. Here it is here in a different figure from a different source, but it shows you pretty much the same thing. The expected demand will be that much split between China, Europe, North America, the rest of the world. The announced capacity will be that 4x. Okay. Why am I telling you this? Because we can look at PV, right? Solar panels. And we can look at the price. This only goes back to 2011. It doesn't go back to the 1990s. Solar panel prices have essentially dropped by 1,000x in the last 30 years. And there was a time when $1 per watt is this level here. $1 per watt was considered completely unachievable. That was the point at which people would say all sorts of things would be unleashed, but it's essentially unachievable. We are now in China at 10 cents per watt, 10 cents per watt, 1/10 of the previous level essentially considered achievable. Right? What does that mean? A 400 watts, 450 watt panel, which is the basic panel, is $45. You can put that up for $45 and it'll give you, under full sun, of course, 450 watts for 8 hours a day for 30 years. It's a remarkable, remarkable achievement. The PV module prices have been driven down to below the cost of materials as of 2024, below the cost of materials. There's no reason to assume that the same could not happen with lithium-ion batteries. What I'm telling you is that China, whatever price, if you're a battery manufacturer, whatever price you say you'll be able to achieve, Chinese manufacturers will undercut that. And they'll continue to undercut it and continue to undercut it until essentially they drive everyone else out of the business, as they have done for PV modules. Why? Because they have a 30-year time horizon. This is an industry that they wish to dominate, and they wish to dominate it for the next 30 years. And we don't have the same tolerance for risk. We don't have the same access to costless capital. We don't have the same access to very low cost labor. So whatever we do in terms of batteries for electrification will be undercut and undercut significantly at every level. And with just enormous overcapacity. And you say, why? Why is this? Because they have a 30-year time horizon, they have enormous overcapacity. They've decided that this is a technology and industry that they will dominate. They also now have enormous numbers of factories that in many cases are co-owned by local authorities, not the central Chinese government, but local authorities. And so there are jobs programs, and they can't give them up. They're essentially riding the tiger, as they say. So any cost you might imagine for a lithium-ion battery to be produced in the West, they will undercut it. What does that mean? It means, for example, in Europe, and I have a slide later, that the first, or maybe it's the second wave of Chinese EVs are entering Europe. They will simply dominate the market because they're being brought in at costs that no established European manufacturer can match, not by a long shot. And they're already 25%. They can grow to dominate the full EV market. Bear in mind that by 2030, pretty much the whole European light-duty vehicle market will be EV. So they can simply destroy the European industries. And you're seeing this, the German manufacturers are now fighting back to a certain extent. But it's very much, they're fighting a rearguard action. It's very late in the day. Okay, so this is American electrical energy production. These small rises, increases, sometimes it increases 1 or 2% a year. And this is China, it's red line here. So China exceeded the United States in 2010 and is now more than 2x. And there's no end in sight. There's no end in sight to the increase in electrical energy production in China. Okay, I want to draw your attention to the following. This is the carbon intensity of electrical energy, which, as you know, is the primary input to in any industrial process for decarbonization, for example. There's the United States and there's China. Again, if we wish to decarbonize the United States, and it seems a worthy thing to do. So the question for the audience, would you pick a country to do it with a lower carbon intensity than you currently have, or a country with a higher carbon intensity? The answer is nobody in their right minds would pick a country or a region that had a higher carbon intensity to provide the materials for you to decarbonize your own industry. That is what we're doing. China is fully 50% higher than us, and we're offloading all of our critical material supply and all of the things that we need, everything from copper to steel to 35 critical materials, to an industry, to an economy that is 50% higher carbon intensity than us. This is not logical. This is madness. This is not good environmental stewardship. This is madness. But we're doing it. This is retail electricity by state on the right-hand side. California is between 25 and 48 cents kilowatt hour at the retail level. And we in Ohio are 6 cents. As I say, it's unconscionable. Our electricity should never be that cheap. But that's an indication for you why data centers, for example, are just moving en masse to Ohio. That power so cheap. The United States is 17 cents a kilowatt hour. That's averaged across the whole of the United States. You can see we're remarkably low compared to countries in Europe. The UK, for example, is remarkably decarbonized. It's 50%. Actually, I have it back here, right? So the UK is not 50%, it's 75% of what we are. But their costs are 2.5x. And you can see Germany, Belgium, Italy, Netherlands, France, Denmark, substantially higher. So they're at an enormous disadvantage compared to us in the United States. China is about 1/2 of our level. Greenhouse gas emissions in a materials constrained scenario, right? So if you had 1 ton of lithium or lithium carbonate or lithium hydroxide, stuff they use, where is it best spent? Well, for a start, I would say it's not best spent in Teslas. It's best spent in a transit bus in New York City or Columbus, Ohio, or Los Angeles or San Francisco or wherever. But secondly, if you did wish to decarbonize, lower the carbon intensity, if you like, of your light duty vehicle fleet, where would that 1 ton of lithium be best spent? You can have, okay. So I said 1 ton, but let's make it 72 kilowatt hours. Why? Because that's 1 EV 4 plug-in hybrids or 44 HEVs, or an infinite number of gasoline vehicles. This is the carbon intensity of your 45 IC engine vehicles, 45 HEVs, 4 plug-in hybrids, or 1 EV is missing. Can I move this?
Should be able to. You can minimize
Oh,
it.
it's minimized.
Yeah.
There you go. So what does it say? It says your lowest carbon intensity is to maximize the number of HEVs. It's not to jump to 1 EV, because you can only run 1 EV and the rest of them have to be gasoline vehicles. You're limited by the amount of critical materials. Once you're no longer limited, or you're less limited, then you go to plug-in hybrids. Then when you're no longer limited at all, then you go to EVs. But you start off with HEVs because you're material constraint. The constraint to the amount of lithium-ion batteries that we can put together. So if we truly wanted to decarbonize, we would acknowledge that this will occur across a significant timescale, and we would go from IC engine vehicles to HEVs, which is sort of a transition that's been underway since the late 1990s with Toyota Prius. Then go to plug-ins, then go to EV. Oh, I've done it now. Doesn't work. Technology adoption rate. People say, well, EVs take up will be as fast as the internet, right? The answer is no, we're in uncharted territory because we've only ever seen uptake rates, very, very steep uptake rates, when the capability of your new technology is significantly better than the capability of the old technology. And that's not the case with electric. Or you either reduce costs significantly and people adopt things enormously, or you offer new capability, increased capability. And it's not the case with EVs, except it's when required through legislation, things like tailpipe emissions reduction, when we introduced fuel injection and catalytic converters or airbags in vehicles. Then uptake rates are significantly high because they're required to be so. So if you take 2011 as sort of the start of this particular EV revolution, because that's when Tesla Model S started taking. The Biden administration said there was no EV mandate, but essentially they did say 50% of all vehicles needed to be EV by 2030 and 100% by 2040. So if you take that as the desired trajectory, we are currently here. What we're doing is essentially flatlining. So the early adopters have bought vehicles, but the middle, the mass market, is yet to buy them. Why? Because they're more expensive and they're less capable. If they're more expensive and less capable in the middle market, who relies on cost and consumer attributes, will not buy them. And that's what we're seeing, running into this consumer resistance. Okay, this is what I was saying about Chinese-made electric cars. They will reach a quarter of EU sales of all vehicles by 2027. All vehicles, the whole vehicle market, will reach 1/4 of that by 2027. That's going to dominate. Okay. This is consumer EV purchase intentions in the United States. This is a Gallup poll from about a year ago. And it shows upper income, sort of 15% of them already own an EV. And the vast majority, sort of 60%, might seriously consider or currently own. That's upper income, $100,000 per family or higher. Lower income, less than 40%, 60% would not consider an EV. Why? Because of cost, because of range, because of capability, and because of the access to charging. But these lower income people don't tend to have their own detached houses, and they don't tend to have their own garages. And that's EV euphoria is dead. This is from a year ago. So automakers are scaling back. You can read the press every day. It tells you about how the OEMs are scaling back on their EV. Consumer acceptability is another issue. And I did say earlier, things like onboard storage and range and refueling capability. A heavy duty truck a diesel truck gains 180 miles of range per minute. Gasoline vehicle is 300 miles per minute. The charger in my garage is 0.35 miles. 150 kilowatt charger is 7.5 miles per minute. So this is the difference. See, and again, it's a consumer acceptability issue. The cost is nice and low, but recharging or refueling is problematic. So government interventions and incentives, I had to add this here. The tax rebates up to $7,500 were rescinded yesterday, though. That's in. Incentives to manufacturers, there's the EVSE build out. Another of his executive orders yesterday said that all money that's yet to be spent on public charging needs to be back. What can the government do? It can have standards, things like V2X connectivity, automation, query, we don't know. And then of course, EVSE charges. So again, why will electrification essentially not trace the trajectory that people believed it should or would? And it's these things in red. Emissions reduction, life cycle assessment. We haven't done a proper LCA on EVs. Gloss over it. The generation of the fuel, we need a 5x build out in renewable energy. Onboard storage is problematic. Fuel dispensing and distribution, which is the chargers, is problematic. Energy independence. Yeah, we produce pretty much all of the electricity that we consume. We import a bit of hydro from Canada, but not the critical materials. Consumer acceptability is problematic and cost is problematic. So, as I say to you, if this is the rubric that we used in the 1990s to dismiss LNG, CNG, methanol, ethanol, ammonia, hydrogen, DME back in those days, this is the same rubric that we should apply to electrification. But decarbonisation summary, electrification is well underway, but there's many, many issues. Off-highway and rail and marine. One thing we learned from the pandemic was that we're absolutely critically dependent upon trucking, marine and rail for the things that we need. Aviation, in many cases, was shut down. Australia, for example, limited air travel into Australia for 18 months. So they survived just fine without air travel, but nobody survived without heavy-duty trucking, rail and marine. Nobody did. Yet, somehow, we've decided that aviation will have access to the sustainable aviation fuel. On-highway, marine and rail are on their own. What they're going to use, nobody knows. Ammonia, hydrogen, DME, nobody knows. And that's wrong. We're trading energy independence for a complete total independence on imported critical materials. Transition is going to be very, very messy. And we've seen it. It's going to cost trillions of dollars just in the United States alone. Perceived as significant uncertainty. This approach needs a reset. We can achieve 90%, 97% decarbonisation of our electricity system if we allow aviation to continue to use the fossil-based fuel. We could save trillions of dollars. Net difference in terms of decarbonisation is trivial, but cost and disruption will keep to a minimum. Okay, so what does that mean? Well, I think there's going to be a reversion to engines and hybridization. Ever improved powertrain efficiency, new engine architectures, hybridization. There'll be increasing electrification. It'll be the consumer has gone back to hybrids and plug-in hybrids, and the industry should do the same. The consumers have seen what I showed you earlier was that the optimum in the near to medium term is more hybridization, and the far long-term goal is electrification. We're going to have fuel tolerant and fuel agnostic engines for a range of bio-derived fuels, ultra high efficiency after treatment, near zero criteria pollutant emissions. Of course, CO2 will still come out of the exhaust if they are carbon-based fuels. But if they're bio-based fuels, then of course we can do the LCA on this. AI and machine learning based engine and after treatment control, improved sensing, including virtual sensing, calibration and diagnostics. And then, of course, ubiquitous V2X communications technologies or powertrain 2X. There's no reason why powertrains can't be smarter than they currently are. And that then is a good segue into vehicle automation, right? There's, as you well know, there's ADS, automated driving systems, which essentially is full self-driving of a vehicle versus ADAS, advanced driver assistance systems. Connectivity a requirement? I think it is. Connectivity vehicle to vehicle or vehicle to infrastructure or infrastructure to vehicle. CV2X is cellular vehicle to everything. The problem with CV2X, it's the same technology that you use on your phone, 5G currently. The problem with it is that it's a non-safety critical technology. So if your phone call drops out, or if you can't Google something, or your chat GPT or your YouTube fails, it's not an issue. But it's needs to be safety critical for vehicle automation. Vehicle automation, it uses machine vision, perception, sensor fusion, real-time path planning and prediction, real-time decision making. But the number of driving scenarios that must be accommodated is absolutely enormous, right? It's hundreds of millions, if not billions. How safe is safe enough? If an AV is just as safe as the average driver, is that good enough? Probably not good enough. The risk and severity of failures, the N+1 problem. The N+1 problem is if a vehicle is that there's a probability and a risk and a severity, and it tails off. But if you truncate at a certain point, the N+1 problem is that the very next potential problem that could occur is essentially as severe as the one that you've truncated at. I'm putting it very badly, but you can perhaps see what I mean. If you train a vehicle for the first 1,000 potential occurrences, it's the 1,001st that'll come back to bite you. That's an issue. Testing and validation of ADS, we don't know how to do it. We certainly don't know how to do sort of the third-party evaluation of the ADS. And this gets to my point. Road traffic safety is the largest issue we face today. And it's truly an existential crisis. In 25 years, we will see over 1 million. We will have seen by the end of next year, I chose arbitrarily 2000 to 2025, we will have seen over 1 million highway fatalities in the United States. Well over 40,000 per year currently. That's an issue. It's a tremendous issue. We're at about one highway fatality every 80 million miles, right? If you push out the pedestrians and vulnerable road users and very old drivers and very young or newly licensed drivers, it's about 1 in every 250 million miles. If you get rid of people driving under the influence, more like 1 in every 500 million miles. So if you want an AV to be better than the average driver, substantially better, it needs to have the intelligence, essentially, of a billion-mile driver. A billion-mile driver, right? It doesn't need to have driven 1 billion miles, but needs to have that intelligence or that capability. It's a tremendous, tremendous issue. There's a large number of other problems, as you know. If you have a very large portion of machine learning or AI in your system, and you trained it, in essence, over that 1 billion miles, each mile in that training carries identically the same weight as every other mile. That's not the way humans work. You remember your close scrapes. You remember your near misses. You remember the day that things almost went bad or did go bad. And AI, unless you train it in that way, unless you tell it, has no such capability. You follow what I'm saying? So people say, oh, we have AI. It's a reflection of the way the brain works. No, it's not. It's a very crude approximation of an oversimplification of how a single neuron works in your head. And that's not the same thing as being human intelligent. It doesn't fall asleep, yes, and it doesn't drive drunk, and it doesn't distract itself and try and change the station on the radio. It doesn't do any of those things. True. But it's a very much a crude approximation, and it can make tens of millions of calculations a second, but it's a very crude approximation of the way in which we work. This is just a cartoon that I showed. The next car program, which I started as RPE back in 2016, was to use very low levels of automation and connectivity to improve the energy efficiency of individual vehicles. Ohio State is a competitor in that. both the first and second phase. But the idea there is that you're marrying connectivity, automation, and the notion of improving energy efficiency. I stole this from someone, ODDs, operational design domains and driving scenarios. If you have a large number of roadway types, roadway surfaces, vehicle speeds, visibility, road signage conditions, what else? Other roadway users, as I say, speed limits, traffic conditions, traffic density, weather, so on and so forth. You can pretty much get to the hundreds of millions or the billions of particular scenario. I Googled show me AV accidents, and I came up with these. And all of these happen to be cruise. I don't know why, because everyone in San Francisco has their phone out. That's a cruise vehicle that ran into a fire truck. That's one that got stuck in a construction zone, didn't know what to do. That's one that drove into wet cement. That's one that hit a bus from behind. That's one that hit a truck attempting to do a U-turn in the street. This is 2022 to 2023 Cruise, Waymo, and Zoox crashes in California, because California requires significant record keeping, and it shows you perception problems, struck from behind, planning problem, stopping in the middle of a left turn in front of oncoming traffic. Unexpected action violates incorrect safety driver input. I've driven in a Waymo cab in Phoenix, Arizona. Has anyone else been in absolutely amazing, an incredible experience. It's just unbelievable to experience. But there's a good reason why they use it in Phoenix. Flat roads, no speed over 45 miles an hour, multi-lane roads, laid out in grid patterns, perfect sight lines, no on-street parking, very good weather most of the year, perfectly benign environment to train AVs. But San Francisco is the exact opposite. It's fundamentally chaos. Second only to New York City, I would guess. And so why Cruise decided to do their work here, nobody knows, but of course they are now out of business. Right, so I found this from Switzerland, which is a fully automated VW ID Buzz. And the reason I showed it is it shows having to interact with people, right? Interaction with. And that brings us to the intersection safety challenge. It's something I worked on at the US DOT. The idea behind the intersection safety challenge is that roughly 1/4 of road traffic fatalities occur at or near intersections. So what if we could use AV adjacent technologies like I showed you before, machine vision, perception, sensor fusion, real-time path planning and prediction, and real-time decision making, take it out of the vehicle and put it in the fixed infrastructure using radar, LiDAR, thermal cameras, and visual cameras. Determine where all the actors in the intersection are, bad actors moving vehicles, and the vulnerable road users, the pedestrians, the cyclists, the people pushing strollers, the people in wheelchairs, people with dogs, so on and so forth. And you look down on the intersection in real time, determine the path planning of each and every individual entity and agent in the intersection, and then you warn people in real time if so-called conflict is likely to occur. And by real time, I mean literally in the blink of an eye, 250 milliseconds or less. And that's the challenge of the intersection safety challenge, is to acknowledge AV technology is advancing, but not as fast as we had hoped. But can we take those technologies out of the mobile domain, put them in the fixed domain, and serve to improve the safety of intersections? So data fusion, AI, machine learning, a low-cost, high-value opportunity. This is a cartoon of it. And again, Ohio State is an entrance in this and has received money in both stage 1A and stage 1B. Now I need to show you the video. This is, yeah, so it's a 3-minute video or so showing you the sort of data that we developed for people to train their systems on.
Redundant.
This is a very simplistic scenario, but there's a cyclist who went across the intersection against the light. This is a nighttime. Yeah, it's so-called occlusion, where the view is partially blocked. So there you see the vehicle actually hit the dump. So why am I showing you this? Because for the first time we have, and showed you 3 scenarios. There's 800 such scenarios, 4 times of the day and night, all weather conditions, all lighting conditions, all traffic conditions. So 3 very simple ones were shown, but including and up to the point of vehicles striking dummies, surrogate road users. A remarkable data set. And it's just been, vast majority of it was just released last Friday by the DOT. The point I'm trying to make to you is there's sort of low-hanging fruit that we can use in the vehicle connectivity and automation technologies that can improve the safety of our roads today. And yeah, it's a remarkable thing. Vehicle automation summary. There's a long way to go in automated driving systems with ADAS here and now. Of course, there are AV adjacent areas that can benefit greatly. Safety is the #1 consideration for mobility. And this is a plot of roadway deaths per million inhabitants. You can see the United States is 4 times higher than Germany on a per capita basis. It's, as our outgoing Secretary of Transportation says, it's a national scandal that we tolerate that much. So again, safety is our #1 consideration. It should be for mobility. Thank you very much. I appreciate your attention. I'm sorry we kept you over time. Are there any burning questions or comments that you would like to make? Yes, sir.
Thank you for the presentation. Just the last slide that you showed, and that's like all countries or like regions were going down, but US has it started
Yes.
going up. Like what caused that? Do you have any?
Yeah, a remarkably good question. You know, our vehicles are remarkably safe. Our roadways are remarkably unsafe. There's a multiplicity of reasons there, but you know, you have to get into the human factors and the human behavior. What induces people to speed? What induces people to speed in an urban area? What induces people to walk across a road in the middle of the night? Those are things that are sort of non-technologically based, and they merely highlight the limitations of our knowledge of what people do and why they do it. But no really good reason, no really good conclusion. But it's terrible. It's awful. We need to do something about it. And the intersection safety challenge is designed to do exactly that. To look down on an intersection sort of with an eagle eye using these AV adjacent technologies and warn and alert people in the blink of an eye to an impending collision. You saw the scenarios that were shown. Yeah, it's a really good question. It just highlights how poor we are at certain things and how we need to do better. Yes.
So, there was a statement made by the CEO of Toyota a while ago talking about he believed that their company would not be moving as swiftly forward with electrification processes like other companies have been, or
Yeah.
automaker companies have been. And a lot of people said that his comments were very like, oh, it's old man, he's just like trying to not change and keep the old ways.
Yeah.
But my question for you is, do you honestly think that a lot of our electrification processes were kind of rushed through with the excitement of like clean or like no tailpipe emissions vehicles? Because I just feel like everybody's like, oh, EV is so awesome, EV is so cool. But your slide that talks about how the materials for one EV could be used for like 45 hybrid vehicles, it's a very good example that I wish people saw.
Yes.
So what do you think about like our timeline?
Well, that's a really good question. So I think, yes, we were all caught sort of swept up in the euphoria, the idea that so again, I think decades hence, everything will be fully electrified. There's no reason not to. But you do need to solve the problems of energy generation, critical material supply, charging, onboard storage. What else? There's the 5, 6 things. They need to be solved. The point of the matter is that we were in a rush to get there, and in the rush to get there, and it was not technologically led, it was policy led. We forgot about the technology. We forgot about the hard realities. We forgot about the consumer acceptability side of things. We forgot about all of this. And Toyota didn't. As you say, they were the ones who said, we see bridges of technology, generations of technology, and everyone said, no, we can leap to EVs. No, it's a, I don't know. We're going to look back on this in the last 10 years, and we're going to be, we're not going to be pleased. Yeah.
So there was a point where you mentioned that an autonomous vehicle might have to have 1 billion miles of intelligence to be considered safe. But do you think that a lot of our infrastructure was developed for human-driven vehicles, and like we have developed our cities, urban planning based on that? Can we do something in our infrastructure? Like the intersection safety challenge was one point, but we design some geofenced areas where we can deploy this technology much more safer in a much more safer environment.
Yeah.
And then that can bring down that training number from 1 billion to like something less.
Yeah, no, I agree. As I say, Waymo in Phoenix, Arizona, or Chandler, Arizona, is that they selected their ODD to restrict that number of variations significantly, and it's worked very well. The issue, there's a number of issues, right? People always ask, especially people in Europe, for example, they say, why does the United States buy 5 million SUVs and pickup trucks a year? They don't need them. And the thing about it in the United States, people buy their vehicles for their 99th percentile of capability. Right? You buy a pickup truck because you go and you collect things from Home Depot once or twice a year, or you go camping, something like that. And that's a different mindset. Likewise, we tend to develop vehicles that are fully capable. In Europe, for example, they have little city microcars, and in Spain and Italy, they have vehicles that are not allowed to go on limited access highways or autostradas or interstates, as we call them in the United States. The US doesn't do that. Every vehicle has to be fully highway capable for safety. So the question is, can we roll things out with limited capability? Or do we require full capability? And again, the Chandler, Arizona is it's a limited ODD, but the vehicles themselves are not limited capability. They're fully capable of driving. They jag I-Paces, they're a very nice vehicle. They get up to speed in the blink of an eye, so on and so forth. We don't tend to compromise on the vehicle side of things. Now, the ODD, yes, they actually can compromise on that. But it's a good point. You mentioned again infrastructure. the AV manufacturers initially said, we will develop vehicles that are fully independent, no dependence whatsoever on the infrastructure. And then they came to realize, no, actually, they do need to pick up lane markings. They do need to pick up signage. They do need to pick up visual cues. They do need to pick them up. Why can't we have signs that have RFID tags on them or something such that the vehicles know? There's an enormous, can you transfer some of the intelligence away from the vehicles into the infrastructure? Then you need it needs to be fully reliable in every respect. You can't have dropouts of data and so on and so forth. But yeah, perhaps there's some compromise that can be achieved. Sorry?
Is this for a battery workforce challenge?
No.
Okay, sorry about that.
No, that's all right. Do you have the room now? We should leave if that's the case.
No, you got it for like 5 more minutes, I think. So
Thanks.
you're all good.
Thank you.
Something specifically regarding ODD for like suppose autonomous trucks, like which can be
Yes.
make it.
Yes. So as you say, a number of trucking companies now do segments of interstate. Again, limited access. It's a much more regular and achievable automation. Yeah. Any other questions? Yeah.
I had a quick question about the data set. I don't know if you'll know the answer to this, but they mentioned that they were using thermal imaging. So how did they recreate the dummies to have the same thermal
Oh,
footprint
right.
as a
They
human?
have the heated vests.
Okay.
Yeah. Yeah. Good question. Yeah, I'd urge you to Google US DOT intersection safety challenge, and the data has been released. So there's people in the room who are involved in the intersection safety challenge. Yeah. But the whole data set has now been released publicly. With the idea of trying to urge people to come up with new and novel ideas and ways of using that data to improve roadway safety. Well, thank you very much for your attention.